Hello, hello. I hope I'm audible. Okay, so let's start. Okay. Hmm. So yesterday we were at this question, right? Longest common subsequence. So this is actually similar to that string problem, standard DP string problem, right? It is also longest common subsequence. So we'll be solving it exactly like that. Okay. So let's go to the whiteboard. For that, let's I think go to 1001. Not really. Maybe. Okay, we'll do it. Oh, we still have yesterday's notes. Yeah, to our left, because the stream is early today, so that is why it is still here. Anyway, LCS array. Oh, sorry. Given two arrays of integers, find the longest common subsequence. A subsequence is a sequence of array elements from left to right that can contain gaps. A common subsequence is a subsequence that appears in both arrays. Okay. 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 We have this. Let's just paste it. Okay. Can you paste it here? Text box. Yep. So we have the input here 8631327482. So how LCS works is basically we have the DP state is like this, right? DP I J is what? Longest or not this maximum length of what? Common subsequence till ith of x and jth of y. So maybe we should zoom it a little. Okay. So maximum length of common subsequence till ith of x and y. Okay. Where x is what? X is our first array and y is second array. Okay, so so this is our DP state. Okay, the transition will be like this. We have conditions, right? If xi is equal to yj, in that case dp of ij will be 1 plus dp of I minus 1 and j minus 1. If it is not, then we have two options. First is that dp of I j be the maximum. Oh no, basically first is that we skip this, skip the ith character and basically how LCS works, right? It takes it tries to compare these two values. Okay, if they match, then it will move on to the next candidate. If it does not match, then we have two options, right? Basically going to this one or going to this one. So similarly, if we have this in the bottom up approach, then what we'll do is we'll choose from either I minus 1 j or I j minus 1, right? That basically it is basically for that we have chosen this value. We have not chosen basic. We have continued scanning the first string here, and we have continued scanning the second string here. Basically, if you can understand from the top-down approach, right? Here we continue scanning the first string, and here we have continued scanning the second string. So basically, if we have chosen this string to continue, then we'll match these two again. Basically, we are always matching I and j, right? Whatever this symbol is, we are always matching these only. Okay, so yeah, that is basically, yep, this is basically the transition. We have the base case, right? This is our state, this is our transition, and we have the base case. So base case is basically if we don't have if the first string length or first array length is 0, then the common subsequence is 0, right? So if I is 0 or j is 0, then basically db will be 0, right? Because there will be no common subsequence. If both are 0, then also it is 0. So yeah, there is the base case is pretty simple, and yep, this should work. And the problem of printing the array, right? Longer sequence, we can do it sorry, we can do it by traversing the dp table. Okay, yeah, we'll traverse the dp table and build the array from there, build the common subsequence from there. Okay, so let's jump into the code. we'll take the input for n and m. Okay, and then we have our arrays, right? We have x of size n and y of size m. We'll quickly take the input here as well. We are done here. DP is initialized with 0 because it is in the global scope, so we don't need to memset or anything, or even set the base values. We can just directly hop onto the loop here. So we can start our loop from, should we start from, okay, let me do one thing. I don't want to do that -1 thing in the string or array comparison, so we'll just do it like this. For int I is equal to 1, I less than equal to n I plus plus scene xi. Just copy this and paste it y and m. Yep. So we'll go from n to n cross m basically. Can we do yeah, it will work. Okay, so again, if I is double equal to 0, it will not be 0, so let's just leave it at that. If xi double equal to yj, and if not, we have two cases, right? Then in that case dp of ij will be nothing but 1 plus dp of I minus 1 j minus 1, right? And if not, then dp of ij will be maximum of dp of I minus 1 j dp of I j minus 1. We have the dp here, and let's just try to print the dp. I j print. So we have 3 here, right? So we have 3 here. So how do we print the common subsequence? So we'll start from the maximum value. We'll start from the maximum value. And then move on to the next value. Of course, we need to check the condition that if it is what do you say, equal or not. So here actually you will get the first one. So anyway, how do we traverse it, right? So let me just print it. I'm doing this so that it is easier to explain. Okay, so as you can see, we have the array here. This is the second array and this is the first array. Okay, the first column is, we have the first array. So basically we'll start from the last value. Okay, we'll check if these two are equal. So how do we check it? If this is the ith row and this is the jth column, we can just check if these array values are equal. If not, we'll move to the maximum, again check for it, we'll move to maximum, again check for it, yes this is equal, then we'll push then the vector 4, right? From here we'll go we'll check which side is the maximum. So we can see that this is also same, this is also same. In that case we'll move here, we'll again check if these two match. No, it doesn't match. So what we'll do is we'll check, is this equal, is this equal, and this is also equal. So no, it will not if it is not here, so we can move to any one of these, right? We can move here or we can move here as well. So if we move here, then no, this will not work because 2 and 7 are not equal. So we'll go to 2 because this is maximum here, right? So 2 will be matched, then we'll go to here, putting 2 in the vector, again 0 1, this is the maximum, we'll go here, 1 matches, go here, and we'll stop at 0, we'll stop at 0. So this is how the traversal will work. Okay, so we have started from maximum value is last value, right? So we have I is equal to n and j is equal to m. We'll go till what? dp ij not equal to 0. If xi double equal to yj, in that case we have our vector int answer. In that case what we'll do is answer dot push back any number, and we'll move where? We'll move to the diagonal position. So I minus minus j minus minus. If it is not equal, in that case what we'll do is we'll check which one is maximum, right? Else if or we can just do it here, I is equal to I minus 1 we'll check. How do we check? We'll check dp of I minus 1 and j is greater than dp I j minus 1. If it is true, then y, just continue from here. We'll go by default, if it is equal also we'll go here only. Okay, let's not do it. Then I minus minus, else of course j minus minus. Should work, yes, should work. And lastly we'll reverse it. Should have wrote down some macros for it. Answer. My typing is also like very bad. got worse actually. And of course we need to print it. One, three, four. Yeah, it works. Yeah, 3 matches also. So yep, this should work. I think. Yep. Oh, sorry. Control C. We need to make new file, right? Because this is not stream. Okay, let's submit it. Over done. So also one more thing, today also it will be a short stream because I have some offline stuff again to do. Yeah, so that is all. Given an A cross B rectangle, your task is to cut it into squares. On each move, you can select a rectangle and cut it into 2 rectangles in a way that all side lengths remain integers. What is the minimum possible number of moves? There is no one in the stream. So we need to cut it into squares only, right? Okay. It is kind of like a knapsack problem. Okay, so can I make a block shapes? Okay, square. Sorry. So we have a 3 cross 5 block. 3 1 2 3 4 5. We have this. Okay, and again we can divide it like this. Oh fuck. Control C, Control V. Okay, so we have this 3 cross 5 block. Okay. What is the question? A rectangle cutting. Okay, so it is a 3 size and here it is a 5 size. Okay, so we can have a we can have two yes okay, so answer for this is 3 only. So 1 second. So answer for this is 3 only. So how it is 3? So one thing I can see is we cut here. Okay, we cut from here. The second cut I can see is we cut from here. The third cut I can see is we cut from here. Okay. So our DP state can be dpij is minimum cuts to minimum moves to cut into square. Base case can be if we have dp of 1 cross 1. This will be 0 only because it is already a square, so we don't need to make it, don't need anymore to make it a square. Similarly, all the 2 2 3 3 and this will also, we don't need to make any cuts, moves for that. Okay, so one thing that we can notice is that suppose we cut here, right? Suppose we cut here at what, 3 3, right? So then we have a 3 cross 2 block remaining, right? We have a 3 cross 2 block remaining then, and if we have a 3 cross 2 block remaining, we'll cut it at 2 cross 2, then we'll have a 1 cross 2 block remaining, and then 1 cross 2 blocks can be cut into 2 1 cross 1 blocks, so basically one cut is there. So we can see that there is a sub problem, right? 3 cross 5 can be cut in many ways. We can cut it here, we can cut it here, basically like this. We can cut here, every single of these piece into a 1 cross 1 block, but that will be actually maximum, so we don't want that. So the optimal here is basically 3 cross 5 to be cut into a 3 cross 3 block, and 3 cross 2 block. Okay, and then since this is a square already, we don't need to go any further. So this 3 cross 2 block, again then it will be cut in a 2 cross 2 block and a 1 cross 2 block. Again this is a square, so we don't need to go any further in this branch. The fuck, banja by square. Chale. So 1 cross 2 will again then be cut in 1 cross 1 and 1 cross 1, right? So both of these are squares, so we don't need to go any further, and it will be our optimal answer, I think, in this case. So how many cuts we did? We did 1 1 1, 3 cuts. 3 is the answer. So how will the DP transition will look like? We can run a loop from any of the length, right? From I is equal to 1 till the last, basically a minus 1, and similarly from sorry, I forgot to mute it. I need to have some hotkeys, key bindings to do that, but we will do it. We'll set up that maybe next time. Okay, so anyway, we can run a loop from 1 to like the length minus 1, and similarly it will be a nested loop. So we can run a loop from 1 to the width minus 1, and in that what we can do is we have these base cases, right? Yeah, we know what the base case will be like. Transition, I think when we do a cut, right? When we do a cut, then what we are doing is okay, we need to do it bottom up. So 1 cross 1 will not be 0. Instead of cutting it, can we do can we combine them? Maybe it is similar. The cutting part is similar to the how many steps it will take, minimum steps take to make 3 cross 5 rectangle from squares. That is the same thing, right? It is the same thing. So of course we can run a loop, check if I and j is equal, and if yes, then in that case what we can do is we can so how do I add? We can check. No, we have already checked. I'm very close, but just how the transition will work. Uh, I know that. Mm, how do I add one to this? If I cut here, then okay. Let's take a simple example. What if we have a 1 cross 5 type thing, right? This is a 1 cross 5. For we have I here, we have j here. Both are equal. We can cut it. dp will be 0 only. J moves on to here. Both are not equal, but 1 cross 2. It is 1 cross 2, right? So okay, so I need to run a loop here also. I need to run a loop here also. I need to run for from this place to this place only we can cut. So what we can do is dp of I j is now here. So dp of I j will be nothing but 1 plus, since we made a cut, or rather minimum of dp I j comma 1 plus dp ik, ik, ik. I and k is equal, so it will be 0. But if I and k is not equal, in that case, you can just fetch it from the dp. So that will be for the one part only. Then again, yeah, it will be 1 plus minimum of the cut. Ij will be 1 plus minimum of the cut that we did. I k comma no on the cut fuck. It is minimum of dp ij comma 1 plus dp I k and plus dp I, and the width will be j minus k. J minus k. Yeah, I might be reaching here, but this looks kind of legit to me. Yep. And the k here will k here will go from I plus 1 sorry 1 to j minus 1. We are slicing it. Okay, so we did it for I, we need to do it for we did it for j, we need to do it for I as well. We need to do it for I as well, and there should be a combination. So how should we do it separately? I don't know. Maybe I should, or maybe not. We have that transition kind of. We have taken a k here to move from here to here. We also can take L maybe to move in the direction of rows, not for rows, not in the direction of rows, for rows. So yeah, we can do that as well. And what is the limit for this? 500, right? So 10 to the power 8. 25. It will go out of bound. It will go out of bound. Time limit will go. Time limit will be a lot. At most we can do is n cube. in that n cube only I need to compute the solution. Maybe n cube will work because the this thing is same as because we can say, right, we can do it. This is a 1 cross 3 as well as a 3 cross 1 block if we just rotate it. So whatever answer we have for the row based, we'll have for the column based as well, right? Maybe, yeah, I think. Yeah, let's try. I'm not sure. We have what? We have int AB, C in AB. We have this. Oh, sorry. No, we have this side. Okay. Again, 501, 501. Base case for int I is equal to 0, I less than equal to what? Maximum of a comma b, I plus plus, and dp I will be 0. That base case is done. Then we have I is equal to 1. Less than equal to a, I plus plus, for int j is equal to 1, j less than equal to b, j plus plus, for int k is equal to I plus 1, j less than equal to a minus 1, j plus plus, sorry, k. We have dp ij is minimum of dp ij comma 1 plus dp I minus ik plus dp I j minus k. No, we are going in the ith row, right? So kj and I minus k. No, it will not work. A is the length. Okay. So I need to do it a minus okay, k a minus k and jk. Done. we in this loop also we can also do it for and k is equal to j plus 1, k less than equal to b minus 1, k plus plus dp ij is minimum of dp ij 1 plus dp. We are going in this direction now, so I k plus dp I b minus k. Okay, answer will be dp ab. Yep. 3 and 5. Let's see. 0. Yep. Why 0? Why 0? Oh shit. Oh shit. We'll do it here. Vector int dp 501 vector int 501, all of it will be 29. Need me know. Fuck. Can we yeah, let me print the okay. For j is equal to 2, okay, we have j is equal to 2 here, so why am I going from, okay, this is not right, and also I is here, right? This is also not right. This is correct. There is some issue. Should not be I. This should be I minus 1. This should be J minus 1. Okay, now what? ij. In all of this code I never use the condition for a square, right? And how do I put that condition? Where do I put that condition? Okay, so the problem is Bro, there should be 3, right? Why 1? So somehow it is not getting updated for 1 2. क्यों? बेस केस भी सेट है, 110 हो चुका है ना। 1 2 के लिए जब आएंगे तो स्टार्ट तो अपन 1 1 से ही कर रहे हैं, कोई दिक्कत नहीं है, कुछ चलेगा नहीं अब। ओके, जब 2 पे आ रहे हैं, जे इज इक्वल टू 2 हो रहा है, तो जे इज इक्वल टू में ये नहीं चलेगा, ये चल जाएगा। तो ये चलेगा, तो डी पी ऑफ 1 2 इज इक्वल टू मिनिमम ऑफ डी पी ऑफ 1 2 प्लस 1 प्लस डी पी ऑफ आई के is what? 1 right now. K is 1 right now. So again dp of 1, b is what? b is 3. 3 minus 1 will be 2. So dp of 1 2. Okay, but dp of 1 2 is not solved. We are solving for dp of 1 2, but again we are using that. So it should not be BK then. It should be JK. Similarly, this should be IK. Yep. Three. Should. Did we solve it? Have we successfully solved it? I think no. Maybe yes. I don't know. Well, it doesn't hurt to submit it. Let's see. Maybe this will be the last problem because we've already taken so much time, and of course we learned something. Did we learn something? Yeah. Please. Holy shit, bro. It worked. Yes. Damn. Wait a minute. Holy shit, bro. It worked. Yes. ओके सो यार हाई है थोड़ा सा, मतलब ये वाला सॉल्व कर ले क्या, मे बी मिनिमल ग्रिड पाथ, ग्रिड वाला प्रॉब्लम है तो should be solvable, but why is the internet so slow, or maybe there is some issue. There is no issue. But wow, I mean, this was like a fluke, honestly. I wasn't sure if it will work or not, but it worked actually. Damn. Go through. Okay. So you are given an n cross n grid whose each square contains a letter. You should move from the upper left square to the lower right square. You can only move right or down. What is the lexicographically minimal I hate string questions, bro. What is the lexicographically minimal string you can construct? I mean, it is simple because we have only two choices. It is not like graph where you can move anywhere, and that problem, right? Word dictionary or whatever, it has like three problems in lead code, 3 or 4, I don't know, I don't remember. No, I think it has only two problems. So basically in that problem, first one uses DFS or BFS, whatever you can use. Second one, you cannot use graph. For that you have to rely on tries, I think, or whatever the data structure is for dictionary words. I don't know, I never learned it. So yeah, I wasn't able to solve the second question that time. It was like giving me TC issues. Here also we have two options. I think it should be easy. Start from the top right. Okay, minimal string, we have to include every. I don't think it is a DP problem. 1 we have A. Okay, if it is same, then we can move to both directions, so I think that will be a DP problem. Then we have A, then we can go here also, then we can go here also if it is same. Okay, so basically our DP state will be DP of IJ is nothing but lexicographically minimal string, but we cannot can we have it in our DP? Can we put string into our DP? In our DP? instead of like making it a dp, okay, we can try to make it we can try to convert the characters into numbers maybe, and then go for the minimum number, and then we'll convert it into string. That way we can, no, I think we can make the string from the dp itself. Yeah, we can make the dp string from the dp itself. We'll go from here. We have two options. We'll choose this one because it is the lexicographically smaller one. Again, we'll go to this one. We have two options. We can go here also, here also. So we'll go in both the directions and see what is the correct way. Okay, we can actually do it from the bottom right. We can start from bottom right and go to bottom top left. Okay. Okay, I think this is it for the stream. I wanted to continue, but since we have some offline engagements tomorrow, so I have to prepare for that. So yeah, pretty good stream today. I think nearly 1.5 hour, 15 minute, yes, plus minus. Okay, so tomorrow we'll solve this question, grid path, and yeah, we'll be able to solve more questions tomorrow actually, because I will be free after that. Yeah, so maybe we can solve more problems tomorrow. Okay, so till then, peace.